Okay, I thought today we might try to do another integral, and we have one here on the board. I have the integral of 1 over 1 minus x squared, all squared, dx. Okay, the first thing that jumps out to me is just looking at the way this piece here looks. Just taking a look at our denominator, it makes me think that maybe a trig substitution might work. And what I'm going to do is I'm just going to set my x equal to sine of t. We'll take a derivative, and then dx is going to be just cosine of t dt. We'll just go right ahead and make the substitution. So in the numerator, we'll have our cosine t dt. And then here I'm going to have 1 minus sine squared t, and this is all squared. But then the good thing here is 1 minus sine squared t is the same thing as cosine squared t. And then because this is squared, we're going to have cosine to the fourth in the denominator, just cosine first power in the numerator. So dividing cosine of t by cosine to the fourth t is going to be 1 over cosine cubed t, or we can write this as secant cubed t dt. But this thing is a really common integral. I'm just going to use this by the formula. So this is going to be half secant t tan t plus 1/2 natural log absolute value secant t plus tan t. And you can get this pretty easily by doing integration by parts on secant cubed and splitting this function into secant t times secant squared t. Okay, so now at this point, all we're going to need to do is back substitute to finish it off. I just want to get myself a value for secant t and tan t because we have those terms here, and that's all we're going to need. And what I'm going to do for that is just draw the triangle over here in the bottom right. And so we have this sine of t, so our angle is t, and we're saying the sine of t is going to be x. We can write it as x over 1. Sine is going to be opposite over hypotenuse. So if we write this as x, we write our hypotenuse as 1. With the Pythagorean theorem, we could find our third side, which is going to be 1 minus x squared. And so now I can get my values that I need. So for tan t, it's going to be opposite over adjacent. So our tan t, I'm going to write as x over square root of 1 minus x squared. And then for secant t, it's going to be hypotenuse over adjacent. So our secant value is just going to be 1 over the square root of 1 minus x squared. And now we just need to plug this stuff in back over here in order to finish it off. So we'll do that. Now here we're going to have my 1/2. Now when I multiply secant t times tan t, we're going to have the square root of 1 minus x squared, but it's squared. So in our denominator, we're going to have just 1 minus x squared. And then 1 times x is going to give me an x here. And then inside the natural log, we're going to be adding these things. So we have the same denominator. So in the numerator, we'll just add the numerators. We're going to have x plus 1 over the square root of 1 minus x squared absolute value plus c. So I'm circling it, and then we'll stop it there. So thanks everyone for watching today. Please like and subscribe. Have a great day.